Hey, Andy. When I walked in here, I was the first student that isn't currently in first period, and I came back. Well, first I put it down and then left. So,
weird principle that like goes on.
what is that? Should I get like you apparel? Oh, no, I'm getting you.
50%.
Dude, what's the
So you're getting out of Mississippi.
Thank you. I want to be a fan. Like looking forward to this.
What is up with your ex? Why is your name up? That's my thing. Why? What is wrong with your ex?
Not bad.
They keep posting like obesity stuff on their Snapchat. They're like eating all this. No, I thought they were vegan. I heard.
Why didn't you unadd?
I don't know how to. My mom never taught me before she told me so. If you click on that phone, you're probably gonna have like 5 different children. Or do you want it straight from the source? Like, what do you prefer? Why? You got something against it? Like your reference?
Okay, charge.
I don't like you. Oh, I shouldn't be saying that.
This is
Hey, Andy, can you teach me how to play Fortnite? I was trying to play the other day. I keep getting like to like the 20s range, but then I keep dying to like all of them. It's like the slipper suit that
I gotta actually walk there.
Also, I don't know how people just appear out of nowhere. Like, I opened one of like those little shed things, and someone was just camping in there. Dude, those booty mountains. Oh yeah, no, I didn't have my volume on when I was playing.
Yeah, that makes sense. They make a lot of noise. You should tell her. If she's a person that doesn't actually tell her when she wants to.
I put my bag over there when I first walked in. Oh, you stupid internet bitch. Hey Lucy, I think Mr. Rand's here today. You know, when I was walking here, I just saw walking out of the background.
I didn't exactly like. I'm praying.
What's wrong with Mr. Rand?
The ring thing.
I made the hair.
You guys fucking with the push drive?
Good morning, ladies and gentlemen. One of the last 2 times you will hear that on the Monday morning for me this trimester, ladies and gentlemen. All right, if you would, ladies and gentlemen, take out your worksheets that we started working on last week.
So you know how like the school's right here, and then pull in right here, and then they go around like this, but then there's so
Guys, I think I figured out the one that people walking in the car. I love the fire walking on Veterans Day. And it happened.
All right, ladies and gentlemen. Couple of reminders before we get going today. Number 1, last day for any missing works or retakes is Thursday. Okay? Must be done by this Thursday. Okay? Your final exam for you guys is next week, Monday at 7:30 in the morning. Tomorrow or the next day, I'll let you know what that final exam is going to look like. Okay? Today, no question of the day. I'm going to give you about 20 minutes or so to work on your balancing sheets. Okay? Then we're going to talk about single replacement reactions and how you can predict them. And then we will give you more time to work on your balancing stuff. So, questions before we get going today, ladies and gentlemen? Well, what is it then?
Huh?
You said yes when I asked if there were questions.
I said adios.
Really? So you're leaving. Thank goodness. The door is there. Go ahead and use it. All right. One correction to make in case I didn't with you already, ladies and gentlemen, and that is on number 17 on your worksheet, ladies and gentlemen. 17 on your worksheet. There is a typo on it. So for number 17, ladies and gentlemen, there is supposed to be an arrow after the first compound in place of a plus sign, and then the arrow after the second compound should be the plus sign. So it is this one thing breaking apart into those three. Go to work, ladies and gentlemen. If you want to work at the lab stations, you are welcome to. If you want to work with pulling a desk or pulling more desks together, completely and/or totally your choice, ladies and gentlemen. 20-minute timer is running. Go.
Can you teach me how to put? Where's like the battle pass thing? Isn't there like a free one? No, it's free. How do you get that stuff? So that's my money at Fortnite. Should I start neglecting my sport? I have a problem with not doing my TV. Yes. I will get you.
That's a good one, because like, definitely.
I mean,
So great.
bless you. Bless you. There you go.
If you're getting decent at the ones at the start, skip and go to the ones at the end where you have to write the equations for everything, ladies and gentlemen.
Okay.
Declan, instead of admiring your crap, maybe you want to get to work.
Well, I was trying to find the cheap thing, but all this stuff was away. Let's say
No, I don't. You can keep it. Thank you. Hang on 1 second. That means no. That means there's something in every single spot. Balance all of the other stuff. People have to do that. And it saves you from every time you put a number down, having to change that, add it up each each time. So I would just hard to
Recommend you.
okay. Go back and go okay.
Mason.
It is correct, but why did you use fewer names? Well, now we have certain, we have 4 and 8, these can all be divided by 4. This is oh, wait. In other words, start with small. Well, but then what happens is, right, what's that balance? All of these things. So how many are working? Correct, but the here, you sit there and really? Oxygen. Okay. So 3 oxygen and 4 oxygen. How many? How many hydrogens do you have here? How many hydrogens do you have here? 6. Okay. So now balance of the hydrogen. Oh, yeah. Over here you have 6 over here. Okay, we're not gonna get 6. Go up here, it's 6. You just check the number down there, you have anything up here. So 2 times 2 is 6. No, these are the ones you didn't write. I was saying that we didn't need to do it. So 2 times 3 is 6. And that's here. So, yeah, but you don't write. So there's I like the one something that we never write. We never write the one with 1.5 up with it.
Oh, number 7 is easy.
That's it. if it says it. So in other words, it says it. So it says sulfur trioxide gas. Sulfur dioxide gas. Yeah. So I'm telling you the little letter that you put down. Okay. Now, a couple of things. Originally, it doesn't end, right? Set this up so that you put coefficient where your coefficient oxygen, you have the right oxygen that way. You write it. So it always has to be O2. We're not going to say that when we say and oxygen gas, which you have to know. Okay, so now we're doing this. Okay, the other thing is up here. Precipitate of aluminum dioxide, what's the charge on aluminum? Okay, sulfur dioxide. So you've got the crystallized gas around. Okay, and then you need to just go in nitrogen first. Okay, that's not nitrogen. Okay, nitrogen is an open.
Other than that one.
If you get to an equation and it's balanced, ladies and gentlemen, just leave it. You're done. You have nothing to do to it.
Not so sure about Oh no.
All right, ladies and gentlemen, back to your seats. Open your computers and get to your EISN, ladies and gentlemen. All right. Today, we are going to start talking about single replacement reactions. Those were the ones that we mentioned last week, Friday. And in a single replacement reaction, you have a lone element and a compound. And the lone element will go into the compound and kick something out of the compound that is already there, if, in fact, a reaction happens. Not every single replacement reaction happens. In other words, some lone elements are not reactive enough to kick out something that is already in a compound. Okay? If they are not reactive enough to kick something out, the reaction is easy. You write down no reaction and you move on because it cannot occur. So first of all, you get to figure out what is going to be produced, and then, ladies and gentlemen, if that reaction will not happen, all you have to do is write no reaction to move on, and you are done. Okay? So, how do we know if a single replacement reaction will occur? The lone metal, not the one in the compound, the lone metal must be more reactive than the metal in the compound. And I will show you what I mean by that in just a minute. But the important part of this, ladies and gentlemen, is to look at your second pink sheet. On the back of your second pink sheet, there is a list of the reactivity of metals. Now, I don't care if you want to make a note on it or not, but the metals at the top are the more reactive ones. Metals at the bottom are the less reactive ones. Okay? So something at the top is more reactive than something at the bottom. All right? So that's what we mean here when we say if the lone metal is higher up on the list, it will replace metals further down on the list. Meaning the reaction will actually happen. If the lone metal is lower on the list than the metal in the compound, you will not be able to replace it and no reaction will occur. Now, we're only doing this with metals, ladies and gentlemen. Where are metals in a compound always? At the beginning. So what you're looking at is the first part of the compound. The metal that is in the first part of the compound. I will not give you a polyatomic or anything like that, ladies and gentlemen. Okay? All right, so here we go. In this reaction, if this reaction is going to occur, what are the two metals that we are comparing in this reaction, ladies and gentlemen? What are they? Iron and lead. So look on the back of your reference sheet, ladies and gentlemen. Which one of those two, iron or lead, is higher up on the list? Iron. What that means is this reaction will occur. Iron is the lone element. It is alone here. It is not combined with anything. Because it is the more reactive metal, it will actually kick out the lead. It'll kick it out and it will replace it. Now, one of the things, I walked around and a few of you are starting to do the reactions where you have them in words and you're writing them down. Please remember, we still need to balance off a compound. You can't just write the metal and the non-metal and be done. You have to make sure that the charges balance off. Okay? So, this reaction does occur. Why? Because iron is higher up on the reactivity list than lead. Okay? So, because of that, the reaction occurs. Now we need to balance the reaction. Okay? We have one iron here, we have one iron here, we have one lead here, one lead here, we have two nitrogens here, we have three here. Yes?
Would francium be like on top of like
Is it on the list?
No.
Is it on the list? Then don't worry about it. We're not going to worry about it. Okay? I know francium is one of the most reactive metals out there. We're not going to worry about it because it doesn't occur in anything. It has a half-life of 22.5 minutes. Okay? Congratulations. So we are going to have to balance this, ladies and gentlemen. Okay, I have a problem with my balancing. What did I do wrong with it? What did I do wrong in my balancing, ladies and gentlemen? I have a typo in it.
There's a 2.
Could you be a little less specific?
The 2 in front of the Fe iron.
Good catch, sir. This should have been a 2 in front of the Fe here because there's a 2 in front of the iron over here, ladies and gentlemen.
Oh, sure.
Sorry about that. If that's wrong in your notes, please correct it because otherwise that will create a problem for you. Okay? So that should have been a 2 at the start. Okay? So once again, ladies and gentlemen, we had 2 nitrogens over here. We had 3 over here. The least common multiple we can get to is 6. So the side that has the 2 nitrogen, I'm going to put a 3 in front. The side that has the 3 nitrogen, I'm going to put a 2 in front to get to 6. This is 9 oxygens times 2, that is 18. This is 6 oxygens times 3, that is 18. 3 lead, 2 iron, everything is balanced. Questions, ladies and gentlemen?
Nope.
Important thing, this reaction actually occurs. If it doesn't occur, you don't have to balance it because there's no reaction there. Okay? All right, so let's take a look at another one. All right. Silver and magnesium are our 2 metals here. Which one is the more reactive metal, silver or magnesium, according to our list, ladies and gentlemen?
Magnesium? Oh, wait. Oh, whoops.
Are you telling me, or are you asking me, or what are you doing, Declan? Because I don't understand when you just holler out elements.
I was on the wrong side.
So which one is more reactive? Which one is higher up on the list, ladies and gentlemen? Magnesium. But magnesium is already in the compound, ladies and gentlemen. So what does that mean?
This is not.
This reaction, ooh, man, having a bad day when I did this slide. Too much copying, pasting, ladies and gentlemen.
No, it's correct. It's just a question.
What?
You should have had a question mark at the end. Does the reaction occur? Question mark. Kg lower than that.
Okay, sorry. Yep, I'm getting ahead of myself. Thank you very much, Declan. I don't like punctuation. Silver is lower than magnesium, so no, the reaction does not occur. There is absolutely no reason to balance it. Okay? Even if you were to predict the products, there would be no reason to predict the products. You would just write down no reaction and you would move on to your next one. Why? Because silver is below magnesium on the reactivity series. Silver is down here at the bottom, ladies and gentlemen. It is like the third one from the bottom. Magnesium is way up at the top. So when we are looking at these, ladies and gentlemen, that is what we are comparing. Here's silver down at the bottom. Okay, silver is down here. Magnesium is up here. This reaction will not occur. Questions? All right. So how about this reaction? What are we seeing? What are the 2 metals involved? If you can't tell me the names, tell me the symbols. Strontium and sodium. So find strontium and sodium on your reactivity series. Here's strontium. Here's sodium. Which one is higher up? Strontium. So now the question is, will strontium replace sodium? Yes, it will. Yes, it will. So strontium will replace sodium. Now, if you're wondering why there's a 2 by sodium here and no 2 over here, it is because sodium is a +1, SO4, sulfate is a -2. We need to balance this compound. Over on this side, why is there no 2 by the SR, strontium? Because strontium is a +2 with a -2 of an SO4. I don't need any subscripts to balance it. Okay? So, oops, sorry. So does the reaction occur? Strontium is higher up than Na, so yes, the reaction does occur. So now, ladies and gentlemen, we need to balance the reaction. Okay? Strontiums, 1 here, 1 here. 2 sodiums, 1 sodium. 1 sulfur, 1 sulfur. 4 oxygens, 4 oxygens. What do I need to do to balance it? Put a 2 in front of the Na. That's it. Boom, it's balanced. Questions? By the way, by the lone element, we put an M for metal. By the compound, we put AQ for aqueous. Okay? In a single replacement reaction, this is the way these will always be. Metal and aqueous. Okay? At least in the ones we do. Questions? All right. So, aluminum metal is mixed with zinc chloride. Will the reaction occur? If so, write a balanced equation. So here's what we have. Aluminum metal plus zinc chloride, which is aqueous. Now, zinc has what charge? +2. Chlorine is a -1. So ZnCl2. If we're going to switch places, zinc will be alone. Aluminum chloride will be the other product. What charge does aluminum have? +3 with a -1 for chlorine. That's why the AlCl3. So I'm comparing zinc and chlorine, ladies and gentlemen. Zinc and chlorine, or I'm sorry, zinc and aluminum, my bad. Here's zinc, ladies and gentlemen, here's aluminum. Which one's higher up? Aluminum. So since aluminum is higher up, does the reaction occur? Yes, it does. Okay? So now you have to balance this reaction. What do we do to balance it? Well, this has 2 chlorines here. There are 3 over here. So in front of the chlorine here, I'm going to need what number? 3. In front of the aluminum and the chlorine over here, I'm going to need, because I got to get to 6. Very good. And then I finish out balancing out the lone aluminum here by putting a 2 in front, the zinc by putting a 3 in front. Questions? Yep, not ready for that yet. Yep. Okay. Hopefully you have a pencil with you, ladies and gentlemen. My suggestion is when you're balancing to always use a pencil. You can use a pen, but man, it may get messy.
Like the Instagram sent you
You gotta make it sure. Mr. Rain's getting out in the session. There you go. You'll have a
Okay. Okay. First of all, ladies and gentlemen, there is a correction to be made on this. Sorry about that. Okay. It has been a long time since I have taught chemistry, and making up my own worksheets, sometimes I get a little bit ahead of myself, ladies and gentlemen. So with that in mind, do not do number 5, cross it off. Do not do number 5, cross it off. Okay? Okay. So let's take a look at this, ladies and gentlemen. Let's start with number 1. Okay. On number 1, ladies and gentlemen. Okay, first of all, first thing we're going to do is check our activity series. We are comparing zinc and what element? Tin. So we want to find zinc and we want to find tin. Here's zinc, ladies and gentlemen, right here. Oops, sorry. Here's zinc right here. Here's tin right here. So which one is higher up? Zinc. So zinc is not in the compound already, correct? So we need to make it so that it is in the compound. So what is the charge of zinc, ladies and gentlemen? Zinc is a +2. What is the charge of nitrate, NO3? -1. So what would our compound be? How about the compound of zinc and nitrate? What would it look like? What would its formula be? Thank you. ZnNO3 parentheses 2. What would be the other product in this reaction? Lead aqueous?
No, tin aqueous.
Not aqueous. It will be a metal. This one will be aqueous. Okay, this one will be aqueous. Now, sorry, ladies and gentlemen, but to conserve paper and not kill trees, we're going to kill trees another way. Pass it around, please. Extra put on the back station.
It wasn't that. It's just
Pass it around and set the extra on the back station.
Okay. The school season is already over.
All right.
For club season.
Now, I did not give you room to balance these. So here is what I would do, ladies and gentlemen. I would take a piece of paper and I would put it right underneath your reaction like this. Piece of scrap paper. And on that scrap paper, ladies and gentlemen, I'm going to put my scoreboard. So I am going to put SN, ZN, N, and O. And I'm going to put it right underneath the arrow. On the reactant side, I have 1 SN. On the reactant side, I have 1 zinc, 1 ZN. I have 2 NO, 2 nitrogens, and I have 6 oxygens. On the product side, I have 1 tin. I have 1 zinc. I have 2 nitrogens, and I have 6 oxygens. What does that mean, ladies and gentlemen? Balance. You don't have to do a darn thing with it. Okay? It's balanced. You don't have to do a darn thing with it. Good. Okay? Now, you are done with that one, ladies and gentlemen. Okay? Now, let's look at the next one. Okay? We are comparing aluminum and nickel. Here's aluminum. Here is nickel. Which one is more reactive? Okay. What that means, ladies and gentlemen, is that this reaction will or will not occur? Will. So, okay. Here I need aluminum. Oops. Sorry, wrong tool. So here I need aluminum. What's its charge? +3. Sulfur, what is its charge? I'm sorry? Thank you. So when I write the compound, what would it be? Al2S3. So you remember that part where I told you in the last unit that if you can't do this, you're going to struggle? Here is exactly why, ladies and gentlemen. Okay? Okay, what would be the other product? Ni. We know this reaction occurs. We have already checked it, correct? Okay, so now we need to set up our scoreboard. Al, Ni, and S.
Would it be Ni2 because the sulfur is 2 and then they cancel out or no?
No.
Okay.
Okay. Right. Run that by me again one more time just so I make sure, because I answered that kind of quickly.
Because it's NiS, would they, since sulfur has a negative 2 charge, would the nickel have a positive 2 charge, so they cancel out?
Yes, yes.
So-
But no, because over here it's nickel alone. Okay? Now, if it were one of the 7 diatomics, you would have to put a 2 by them. But good question. Here is what happens. Here it is charged. Nickel would have a +2 charge, like you said, because sulfur has a -2 charge that balances out. Hey, guess what? Over here, nickel no longer has a charge. So not only have you, has aluminum kicked out nickel, but nickel has actually gained a couple of electrons to go from being positive in this compound to being neutral here. But aluminum, which was neutral here, did not have a charge, loses electrons here to combine with sulfur. Okay? Ultimately, ladies and gentlemen, we don't need to track electrons, but they would work out in this reaction. The number of electrons gained by nickel would have to be equal to those lost by aluminum. Okay? What we do need to worry about, though, KP, is making sure that this compound has its charges balanced so that it has a total charge of 0. When we write the lone elements, they will always have a charge of 0. We don't need to do anything with them. And since I'm only giving you single replacement reactions where a metal replaces another metal, you shouldn't have to worry about any diatomics. There won't be any O2s or N2s or I2s or things like that in these. Okay? Questions? Good questions. All right. So we have 1 aluminum over here. We have 2 over here. We have 1 nickel over here. We have 1 nickel over here. We have 1 sulfur over here. We have 3 over here. All right. What do we do to balance? Don't everybody shout out all at once. I can't hear you when you do that, please. What do you want to balance first, Jasmine? Pick something. Aluminum, okay? Which side needs more aluminum, Jasmine? Okay, so what number do you want to put in front of aluminum here? Good. That will balance off the aluminum. Good, done. Okay? So now we got to go to sulfur. Michaela, what do we do to balance off the sulfur? On the where? I'm sorry. Okay, so here's our compound containing sulfur. I'm going to put a 3 in front of it over here to get 3 sulfurs. But now what else did I change? To how many? So we finish off by balancing it by the nickel on the product side, putting a 3 in front. Everything is balanced. Your reaction is done, ladies and gentlemen. That is what you need to do. Questions? Okay. So let's go down, ladies and gentlemen. Let me clear this up. Let's go down to number 6. Okay. All right. All right. Cobalt metal, +2 ion in a compound. Now, when we write cobalt metal, do not worry about that +2 ion part yet. It is not in a compound. So we are going to write CO with the little m after it. That is how we write cobalt metal. Lowercase o, m after it. Is mixed with aqueous lead 4 nitrate. Now, what's the symbol for lead? Pb, and its charge is a +4. What is the symbol for nitrate? NO3, and its charge? -1. So what would the compound look like? Nope. And then we put AQ after it. Yes, Michaela.
Periodic table, your lowest rank could be either 2 or 4.
Right, but it's telling us in here with the name based off of the Roman numeral. But good point. Thank you. Okay. So now the question is, where is cobalt and where is lead? So here they are, ladies and gentlemen. Here is cobalt, here is lead. Which one is more reactive? Cobalt. So will it replace lead? Yes. Okay. So now it is going to replace lead. So we are going to have cobalt. What charge is it? That's where the +2 in parentheses here, +2 ion in a compound came in. Okay. And nitrate is still NO3, and what is its charge? So now when we put these two together, what do we get? Correct. AQ. And what else? P what? Perfect. Okay. Now all we got to do is balance it. Now all we got to do is balance it. So again, on your paper, CO, PB, NO. 1 cobalt over here, 1 over here. 1 lead over here, 1 lead on the product side. 4 nitrogens on the reactant, 2 on the product. 12 oxygens on the reactant, 6 on the product. Okay, so what do we do to get it balanced? Well, we need more nitrogen on the product side. So here's the compound with it. So we're going to put a 2 in front there because 2 times 2 will give me 4. 2 times 6 oxygens will give me 12. Now, what else did I change, though? So now I put a 2 in front of cobalt on the other side. Boom. There you go, ladies and gentlemen. Questions? Yes, no, maybe so, ladies and gentlemen. Rest of the hour is yours, ladies and gentlemen. You pick a worksheet you want to work on and you get to it. By the way, ladies and gentlemen, on your sheet of paper, when you do a scoreboard, if you do it like this, ladies and gentlemen, over in the corner, when you do the next one, just slide over and do it here. Do it next to it. Something like that. And you could keep working your way around your paper. You could fold your paper so that you're not looking at the old part and you're using the new. Okay? So find a way that works for you, ladies and gentlemen. Find a way that works for you to use this for more than one problem, please. reaction occurs. Do not write any products. Do not even do the reaction down at the bottom. Just write no reaction if no reaction occurs. Bless you.